Hey there, algebra class. Let's start by looking at Wednesday's warm-ups. So we did one of these on yesterday in the notes. Okay, so we want to distribute. We're raising this parenthetical, right? Something with parentheses. We're raising this parenthetical thing to the 1/2 power. So we're going to be distributing 1/2 to all of your terms in your parentheses. Okay, so anytime we have something in parentheses raised to a power, the first thing we do is distribute it to everybody. So this is 100 to the 1/2, x to the 8th times 1/2, and y to the 16th times 1/2. Because when we have a power raised to a power, we are multiplying those exponents together. Okay, we are multiplying the powers. So that's whether it's a 4 or a 2 or a 1/2 or a 1/3, right? The power doesn't matter. If it's outside of parentheses, then you are multiplying them. So what we talked about in class was this 1/2 power is better known as the square root of the number. So rather than raising a number to a 1/2 power, we're going to interpret the 1/2 power as the square root. Okay? Because that's what it means. The raising something to the 1/2 power means we are taking its second root, or the square root. Okay? So let's evaluate this. If you have a calculator and you need it to help you, that's fine. The square root of 100 is 10. The square root of 100 is 10. And then x to the 8. 8 times 1/2 is 4, and 16 times 1/2 is 8. So our final expression is 10x4, y8. Let's see, is that an option? 10x4, y8. Well, there's two of them by Jolly. There's one here and there's one there. That's strange. Two right answers. Interesting. Well, either way, 10x4, y8, no matter which one you might have picked, that's the right answer. Okay, and then the second one says, which of the following expressions cannot be simplified? So which one does not have a multipliers that can be reduced to something that is doubled? So let's look at 12. What numbers multiply to give us 12? Right, 6 and 2. Well, that's not one. A 6 there and 2 here. Can we further simplify 6? 2, 3, and 2. Okay, so because there's a pair, that means 12 can be simplified. Okay, root 12 can be simplified because we have a pair when you do your factor tree. Okay, let's look at 15. What numbers multiply to give you 15? 5 and 3. Can we simplify 5 any further? No. Can we simplify 3 any further? No. If that cannot happen, if you cannot simplify your first factor tree anymore, that means 15 cannot be simplified. Okay, it does not have a perfect square multiplier within it. Okay, 49 is 7 times 7, right? There's your pair automatically. And 9 is 3 times 3. There's a pair also. So anytime you perform a factor tree prime factorization and you get two of the same number, that means your radical can be simplified. And if you perform a factor tree and you get numbers that can't be simplified or don't have a pair, that means it cannot be simplified, right? You had one of those questions on your assignment from yesterday also. Which one cannot be simplified? Okay, I'm sure you've got one like this on your test, so let's talk about it first. Okay, we are going to start by looking at the numerators and simplifying the numerators by itself, and then we're going to turn around and simplify the denominator by itself. Okay, so let's do that first. Simplify your numerator and simplify your denominator. Okay? So when we're doing this on top, we are multiplying numbers. Numbers always multiply to other numbers. So we have 5 times 4. 5 times 4 is 20. So we have 20 on top also. And then do we have any like numbers? I have an x term here and a y term there and a z term. So there's nothing to combine. So I'm just going to write them down as I see them. So x to the minus 3, y squared, and z to the 5th. Okay, and then I have my denominator. What was that? That was weird. My denominator, so I'm going to do the same thing. Are there any like terms at all in my denominator? There's a 2 term, there's an x term, a y term, and a z term. There are no like terms. That's just going to stay at 2, x to the minus 1, y, and z to the minus 2. Okay. Now, here's the way these powers work. We're going to be reducing our numbers. So we have 20 divided by 2. What does 20 divided by 2 give us? Right, 10 over 1. Right, so we're going to try and leave this as a fraction to see if we have any denominator. So 10 over 1. Okay, now our next term is the x. And what do we notice about the x in the numerator? It's a negative 3. Okay? So whenever we have a negative power, this negative power goes to the bottom or the other side, right? If it's on the top, it goes to the bottom as a positive. And if it goes to, if it's a bottom negative, it goes to the top as a positive. Okay? So we're going to keep our x's in your denominator. So this is going to be x to the negative 1 plus 3. Okay, so there's your denominator line. Because we have a negative 3 on top, we're going to add it to the x on the bottom. Okay. Which y is bigger, the top or the bottom? Which y has a bigger power? The top y or the bottom y? The top y. So we're going to take this y and we're going to bring it to the top. Right? What is the exponent of y on the bottom? It's an exponent of 1. If we don't see an exponent, we can assume that it is a 1. So we have 2 on the top, and we have that 1 on the bottom. So we have 2 minus 1 as your y power. Okay, and then what z is larger? Is z to the 5th larger, or is z to the negative 2 larger? Hopefully you know that z to the 5th is larger, which means we're going to move our negative 2 up to the top with the larger term. Okay? Yes, x, negative 1 is larger than negative 3 because it's closer to 0. So we're going to be doing the opposite operation. So it's a negative on the bottom, which means it becomes a plus when it goes to the numerator. Just like our negative 3 in the numerator became a plus 3 when it went to the denominator. It changes sign from a minus to a plus when you change from the top to the bottom or from the bottom to the top. So this is z to the 5 plus 2. Okay. So let's simplify. We have a denominator and a numerator, so let's draw in your line. And everything on top. We have a 10 on top. What is 2 minus 1? That's just 1, so we have y, right? It doesn't need to have a power on it because it's just y to the 1st, and z to the 7th power. 5 plus 2 is 7. And in the denominator, negative 1 plus 3 is positive 2. So 10y z7 over x squared. 10y z7 over x squared is option C. 10y z7 over x squared. Okay, so those are the kind of things we're going to see on your test tomorrow. So let's pass out the review and go over it also. So here's our review paper, right? These are your exponent rules and your radicals. So that's what your test is over, exponents and radicals. Okay? Okay, so there's a poster there about the exponent rules, and we need to remember the radical has two parts, right? Your fractional power has two parts. It has a numerator, that is your power, and a denominator, which is your root. So let's look. What operation are we going to do to our exponents here? What is the operation? It's either add, subtract, multiply, or divide. So what are we going to do? We're going to add them together, right? So this is anytime we have multiple letters, we are adding their powers together. This is n to the 4 plus 5, which is n to the 9th power. So anytime we have multiple letters, multiple bases, we are adding their powers together. Okay, numbers multiply to numbers. What is negative 2 times positive 3? Negative 6. And now we have your variables that we have to add their powers together. So we have an x and an x to the 4th. So we're going to add them. Notice, of course, when you don't have a power, that we're assuming the power is 1. Okay, when there isn't a power explicitly given to you, we can assume that the power is 1. Okay, same thing for the y. The y term doesn't have a power explicitly given, but I think you can assume that is going to be a 1. So this is y to the 3 plus 1. So our final answer is negative 6 x to the 5th and y to the 4th. Okay, oh, here we have a power raised to the power. So what is our operation that we're going to do with the 2 and the 5? We're going to multiply them together. A power raised to a power means we are multiplying the powers together. So this is y to the 10th. Okay, let's go just straight down. I know that's not very the way we go. We usually go in order, but let's just go straight down. So we have to simplify 4 over 24. Where is the bigger number? In the denominator, so our division, which is going to be 6, because 24 divided by 4 is 6, that number is going to stay in your denominator. So when you divide both of these by 4, we get a 1 on top and we get a 6 on bottom. Okay, so where is the bigger m power? The bigger m power is in the bottom, which means the 5 is going to come down to the bottom and join the m in your denominator. And we always do this by changing the sign. So it's a positive 5 in the numerator. It becomes a minus 5 when it goes to the denominator. And then for n, which one has the bigger power, the top or the bottom? The top one does, 3. So we're going to bring this n power up to the numerator. 3 minus 1. Okay, so we're going to take your variable to wherever the quantity is larger. So m to the 7th is larger than m to the 5th, and n cubed is greater than n to the 1st. So we have n2, n to the 2nd power, or n squared on top, and we have 6m squared on bottom. Okay, so the hard thing is, where do we put the powers? You always try and keep them wherever the variable has the larger power. So m7 is larger on bottom, so your m answer is going to be on the bottom in the denominator. Okay, coming back, here's a similar one. Right, in this case, both of our numerators have greater powers in the denominator. So we will be bringing the 5 up to the top as well as the 2. Okay, and this is a subtraction problem. X to the 10 minus 5 and y to the 8 minus 2. So we are subtracting, right? They changed signs. It was a positive 5 in the denominator. It's a negative 5 in the numerator, or a subtract 5 in the numerator. So the final answer is x5 y to the 6th. Okay, number 4. Well, here we have once again a power raised to a power. So we're going to be distributing. The negative 6 gets squared. The a squared gets squared. So this is multiplying. A to the 2 times 2. And b gets squared also. B to the 1 times 2. Okay, so we have a parentheses raised to a power, which means we are distributing that square into all of our terms. So negative 6 times negative 6 is positive 36, because squaring something makes it positive. And this is a to the 4th power, because 2 times 2 is 4. And this is b squared, because 1 times 2 is 2. 96, holy bejeebers, what is that? Oh, okay, first we have to deal with your denominator, because your denominator has parentheses raised to a power. Okay, so let's leave the numerator alone for a second and look at straight just our denominator. So we have 96 x to the 8th, y to the 12th. So now we have to do our distribution. We're going to raise 2 to the 3rd power. We're going to raise x squared, so x to the 2 times 3 power, and y to the 1 times 3 power. So nothing changes on top yet. We haven't messed with the numerator, so that's still 96 x 8 y 12. But let's simplify your denominator. What is 2 times 2 times 2? Remember, that's what it means to raise something to a power, is to multiply it by itself that many times. So 2 times 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. And then this is x to the 6th and y to the 3rd. 2 times 3 is 6. 1 times 3 is 3. So now maybe we should get out our calculator so we can do what is 96 divided by 8. 96 divided by 8 is 12. Right? 8 goes into 9 one time with the remainder of 1, so 1, 6. 8 goes into 16 12 times. And then the numerator has the larger power. So this is going to be 8 minus 6, which is x squared. And once again, the y numerator has the greater power. So 12 minus 3 is y to the 9th. So our final simplified answer is 12x squared y to the 9th. What's going on here? First, we should do what to these powers? We're going to multiply them. A power raised to a power is multiplication. So 3 times negative 2 is negative 6 over x to the minus 7. Which is closer to 0, x to the minus 6 or x to the minus 7? X to the minus 6's, which means we're going to bring your minus 7, which is smaller because it's farther away from 0. Right, it's a larger negative, but it's farther from 0. You're going to take your negative 7 and we're going to move it to the top. Okay, and its sign changes. So what's the opposite of negative 7? Positive 7. So this is x to the negative 6 plus 7. When a negative goes from the bottom to the top, it becomes a plus. So negative 6 plus 7 is positive 1. So your answer is just x. If the expression y4 at y to the minus 2 raised to the 3rd is equivalent to y to the n, what is the value of n? Okay, so this is just asking us to do this all over again. Negative 2 times 3 is y to the minus 6. And since we have multiple y's, we're going to add their powers together. So y to the 4 minus 6 is y to the negative 2 power. So what is your exponent? Your exponent is -2. Okay, so this question is just asking you to identify the exponent when you simplify your expression. Okay, let's squeeze over to number 10. Oh, geez, this was like our warm-up one, wasn't it? Okay, let's deal with the numerator first and with the denominator second. Okay, all by themselves. So let's simplify this to begin with, and then we'll simplify this secondarily. So first we need to multiply our numbers. We have 6 times 2, which is 12. And then I have an x value, a y value, and a z value. So there are no like terms to combine. So we have x to the -4, z to the y cubed, and z to the 7th. Okay, it looks like there's nothing on the bottom I need to combine either. There's an x term, a y term, and a z term. So 18x to the -2, y to the 5th, z to the -3. Okay, so we have to deal with this just like we did with our warm-up one. Okay, we deal with our numbers. 12 and 18, what do they have as a common multiplier? The answer is 6. 6 multiplies into 12 and 6 multiplies into 18. So 12 divided by 6 is 2. And 18 divided by 6 is 3. So you have a 2 in your numerator and a 3 in your denominator. Okay, so the x ones, which of your x powers is closest to 0? Hopefully you know that that is -2. So we're going to bring our -4 down to the bottom of your denominator with your -2. Okay, you always take the term farther from 0 and you move it to the one closer to 0 if they're negatives. So this is x to the -2 plus 4 because you change the sign from a negative on top to a plus on the bottom. Okay, which is our larger y value? I believe 5 is, so we're going to take our 3 from the top and move it to the bottom with your y. So it's 5 minus 3. As the positive 3 on top changes to the bottom, it becomes a subtraction. And then z, we're going to take our minus 3z and move it to the numerator. So z will be 7 plus 3 in your numerator. Okay, so these ones with the minuses on the top and the bottom are probably the most difficult of the ones that we're going to see on your test. Okay, but that doesn't mean that we can't do them. It is still obeying your rules. So in the numerator, we have 2z to the 10th power. And in the denominator, 3x squared, y to the 2nd power also, 3y squared. If the width of a rectangle is that yards and the length is this yards, what is the area? So area is length times width. So this is another way for these crazy writers to get you to do your multiplication of powers. Okay, by throwing in a geometric relationship. So geometry says the area of a rectangle is length times width. Here they give you a crazy length and a crazy width, and they want you to use the rules of exponents to simplify. Okay, so we have 3 times 8. Your numbers multiply to each other. 3 times 8 is 24. Here I have g to the 1st and g to the 4th. So 1 plus 4 is 5. And I have h to the 5th and h squared. So we add them together. H to the 5 plus 2 is h7. Simplify 3 times the square root of 45. All right, so we're going to think about what numbers multiply together to give us 45. And the most obvious ones are probably 9 and 5. Okay? And then can we further simplify 9? We sure can, into 3 times 3. And this is what we're looking for when we are simplifying a radical, is a multiplying pair. Because every multiplying pair contributes a number to the outside of your radical. And anything that's not a pair stays underneath your radical. So our 3's have a pair, so they contribute 1, 3. Right, there was already a 3 on the outside, which is the one in black there. And then the 5 is solo by itself, so it stays underneath your radical to give us a final answer of 9 times the square root of 5 as the simplified version. Okay, here's one like our warm-up. We're going to distribute the 1/2 into all of our terms. And remember, 36 to the 1/2 is better known as the square root of 36. And the other ones are multiplied. So x to the 4th times 1/2 and y to the 8th times 1/2. Okay, what's the square root of 36? The real number 6. And half of 4 is 2. Half of 8 is 4. So your final answer is 6x squared times y to the 4th power. Okay, 14 was similar to our previous one. Which one cannot be simplified? So we're looking for its multipliers. 49 is 7 times 7, right? There's a double. 50 is 25 times 2, or 5 times 10, I guess. Could have done 5 times 10. But 25 is going to be 5 times 5, right? There's a double. So that means it can be simplified. 33 is 3 times 11, right? Neither of which can be simplified any further. So root 33 is a number that cannot be simplified any further, because it doesn't give you any factor pairs when you do your factor tree. And lastly, 240, holy bejeebers. Okay, I know 240 is, it's 2 times 120, but it's also 24 times 10. Right, 24 and 10 are much smaller numbers, a little bit easier to deal with. 24 is 6 times 4. Is that what you see, or 8 times 3? And 10 is 5 times 2. Okay. 6 is 3 times 2. 4 is 2 times 2. And that's all the way down to your prime factors. So let's see. Where are our pairs? We have a pair of 2's here. And I have a pair of 2's here, right? Here's another pair. They're not connected to the same number, but they are in fact a pair. So they'll give us another 2 on the outside. And do we see any other pairs? Nope, there's a 3 left over and a 5 left over. So both of those numbers are going to go back underneath your square root, or your radical. So our final step is to multiply these things together. Outside times outside. 2 times 2 is 4. And 3 times 5 is 15. Right? That's a pretty intense problem that had a lot of factor trees to go through. So hopefully this helps your brain and you will be successful on your Algebra 1 test tomorrow over Unit 5.